Okay, part 2 of our grade 9 math lesson on slope. Looking at a few more examples. We're going to use the slope formula. We're going to draw lines, all that great stuff. And this first question, I don't think I worded it very well, but it's just saying find a point B that would fall on a line. That part's not very clear, but that would be on a line that starts at A, right here, which are those with those coordinates, and it has a slope of 2. So the first part of this I think you got to get your head around is the idea that, what do I mean by 2? Well, first of all, it's plus 2. It's a positive slope. So you can picture it's going to go in this direction. And the other thing that we know is that, so you might see the 2 and think, well, what does that mean? Like, it means 2 over 1. Right? 2 is the same as 2 over 1. That means when we think rise and run, the rise must be 2, right? The rise is 2, and the run is 1. And so, I would say it as, if I'm just drawing it on a grid like this, I'd say up 2 over 1. Okay? Up 2, rise, over 1, run. So I would just then find, to draw a line, you only need 2 points, but we'll draw a few. But I'm going to follow this pattern, up 2 over 1. Go up 2 over 1. Up 2 over 1. Up 2 over 1. So that's enough. Like, I can now create the rest of the line. And so all you do, take your straight edge. It starts at A, it said, and just draw through those points, and that's the line. I do have an arrow on the end here, which is theoretically, I guess it could go forever. And the idea of point B, well, point B could be any point on that line. So, I could just say, okay, I'm going to make this point B. And it has coordinates. What gives us coordinates of, what would that be? 3, 4, 5, 6 in the x direction, and 3, 4, 5, 6, 7 in the y direction. Okay? So, but B, like literally, there could be, and I mean literally, there could be an infinite number of answers if we used numbers that had decimals, right? But I just chose one that kind of fell nicely and decided to take it. So 6, 7. Okay, so that's, again, if I'm going too fast, Mr. Bridge or your teacher will pause it for you, but I'm going to move on to the next example, which is really the exact same example, except this time it says a slope of -3, and it's starting up here. So -3, so we have a negative slope, okay? And so we know basically what it's going to look like, because we were playing with positive and negative slopes earlier. And the way you think of a slope of -3 is it's the same as -3 over 1. So you have a rise of -3 and a run of 1. So down 3 over 1. That's how I would say that. So, the -3, just think of it going with the rise part. And it's easy, okay? So then my next point on the line would be go down 3 over 1. Down 3 over 1. And you can just keep following that step pattern, okay? And I'll show you something on the Desmos in a minute with step patterns, by the way. But I'm going to start it here at, go through those lines. And I can pick any point on that line. I might as well pick one I've already got right here. Let's figure out what the coordinates of that point is. We'll make that B. But like I say, there could be an infinite number of answers. And so if I gave you that on a test or something like that, you could just pick any point on that line. Okay, it doesn't have to be, I'm just picking one. So this one on the x's, that's 2, that's 3, so it's going to be 4 on the x. And the y coordinate, I'm just going to count down from 15. So 14, 13, 12, 11, 10, 9. Okay, so that's finding that's finding a point on a line, and that's how you draw the line, though. You figure out the slope, kind of break it down into rise and run, and then if you're lucky enough to have a grid where we're just saying that every box is just a unit of 1 down or 1 over, that's how you do it. Let's look at this step pattern. I wanted to show you this on Desmos. If you could open up your Desmos. It's kind of a little app they have. How does it go? Here. Visualizing slope. So, just what I just did then. Oopsie. so you can follow me, or you can just look on the screen if you want to. You don't have to go along with me, but so it's under this open graph, the lines there. There should be one that says visualizing slope, so you grab it. And the idea is this. This is showing a weird slope of 1.82, so let's make a nice even slope of 1. And what this shows is sort of the step over 1, up 1, over 1, up 1. And then this gives you sort of the ability to make it steeper, so that would be a slope of 2, right? Now I'm going over 1, up 2, and it's just showing the idea of it being steps. And you can play with it even and bring it sort of down like that, and that would be over 1, down 1. We have a slope of, it's rounded, it's not rounding very nicely, but let's see if I get it perfect on 1. So a negative slope, the m, by the way, is a slope. There we go. So now it's going over 1, down 1. And this is just showing, here's the line, but this is showing the step pattern. That slope is really just a step pattern. Okay? And you think of it in terms of rise and run. And the over is the run, and the either up 1 or down 1, or 2 or 3. So that's like a half right around there. So that would be over 1, up 1/2. That sort of idea. You go ahead and keep playing with that if you want for a minute, but you'll have to pause because I'm moving on with the note. Okay, so here is a formula for slope, and you'll see us use that pretty shortly. But what this means is, it looks weird, but really what's it saying is x2 minus x1 is like the change in x, and that's the run. It's just another way of saying rise over run, but it's more applicable if you're dealing with points on the line. So I wanted you to write down the formula. We will be practicing with that in a minute. So if ever you have 2 points on a line, you can use this formula, and I'll show you how. If we want to jump to this example, I'll come back to this one, okay? But let's jump to this example. Here I've got a grid, and it says, okay, and it gives us a table of values. And it asks us to find the slope, identify if the line is partial or direct variation, and graph it. So first of all, as far as finding the slope, here's what you do. You can pick, and I just chose these two. See where I've outlined in red? I've chosen those 2 points, and I've decided to call this one x2, y2, kind of the second point, and the first point x1, y1. You could choose any 2 points you want, and you can find the slope. I chose these because I like zeros. They're easy to do math with. And then I just chose the first one on the grid. So you can, I could have picked those two. To stay with all positive maybe is another nice thing, and then there's no all positive in this one. But if you have all positive numbers, sometimes it's easier for using the slope formula. But, so I'm going to show you. Here's the basic slope formula, and I'm going to take these points and plug it into this, okay? So here, so y2 is going to be the 0, and y1 is 6. So that's why it says 0 minus 6, because I'm just subbing in 0 and 6 for those. And then in the x, x2 is 0 again, and I have to minus it, right? But I'm minusing a negative 3. And maybe you hopefully remember that subtracting a negative is the same as adding a positive. So to solve for my rise and my run, then I have negative 6 on top and just 3, because, right, 0 minus minus 3. Your team is at 0, and you lose 3 bad players, you become a plus 3, okay? And then that divides out to minus 2. So that is calculating slope. We'll do another example in a minute using the formula. It says to plot the line, identify if it's partial or direct. You might remember this from yesterday. I know right away this is direct because there's a 0, 0 point. That means that it's going to pass through here on the line. Okay? Which, by the way, I can pick that when I want to plot it here. I can pick that as a start point. So right there, there's my first point, 0, 0. And then I can either pick another point and connect the dots. In this case, you can. But I'm going to use the slope, because I have a slope of minus 2, which is the same as minus 2 over 1, right? So what I'm going to do is take the 1 point here, 0, 0, start there, and then use what I told you earlier of this would be down 2 over 1, down 2 over 1. There's another point, down 2 over 1. There's another point. Now I've got enough points that I can create a line. So I'll start it here, but I'm going to make it grow in both directions. Okay. And I'm going to actually change it so that it has arrows on both ends, and you should be writing this as you go. And I'm going to make it go off in both directions because there's no reason why it can't. Okay, I might just change the color too. So that is, so we've done the slope. We calculated it using the slope formula. We identified direct because and the reason it's direct variation is because it passes through here, and I've graphed it. Now we can also graph this in Desmos though, and why not? Why not keep playing with it? So if you join me and flip after you get this written down, again, Mr. Bridge might pause it, but I'm going to move over to the Desmos, and we're going to graph that line. And how you graph it in Desmos is all you need is 2 points on it. So I'm going to go to Add Item, Table. You can do this along with me if you want. Now I can't use x1. Let's see, what are our points? I'm going to choose -3 and 6 for x1, y1. So -3 and 6. So I got to go to here and turn that into a -3, and here and turn that into a 6. And the second point I'm using is 0, 0, right? So that's 2y2, so 0, 0. And then I'm going to get rid of this, get rid of this, and get rid of this. So all you need in Desmos to plot a line is to have 2 points. So I just took the 2 points that I chose in the beginning. And now what you do, and if you don't get this, you can follow along and re-watch it to practice it. We'll practice it lots throughout the unit if you don't get it today. But you come down to this, and it says expression. You hit that, and you go y1. You have to do this. Okay? So let's go back. I'm going to erase all that and start over again. So you see y1, because that says y1. And then you can't use equals, you have to use this. And you have to use m x1, and then you add b. And this is the general form of the equation. We talked about that yesterday. The difference being this is actually proportional, or approximately equal to, but we're just going to use, that's how we're just going to draw the line. And that's going to draw the line that we have. It says 0, 0, -3 and 6 if I scroll out a little bit. There's -3 and 6. There's the other point. So I've got my line. The other thing this tells me is it tells me the slope is -2. Okay? So this actually, you could do this question almost, and by plotting it, you can see it passes through here, so it's direct variation. You can answer all the questions. Slope, direct variation, because it goes through 0, 0. What else did the question ask us? I'm jumping away. And plot it. Well, it's plotting it on the grid. So anyways, that's that one, and let's do another one just like it. Okay? So same question again. This time just a different set of data, all the same requirements for the question. I'll do it by hand, and then we'll do it in the Desmos as well. Okay? So first of all, choose any 2 points. I always look for positive points. Okay? They don't have to be. I could choose any 2 I wanted, but I chose 2 positive because it makes a better chance I won't make a mistake over here. So I chose this one to be 1s and this one's to be 2s, just in order that they're in there. And I just sub in the numbers. So y2 is 9, y1 is 1, x2 is 4, and x1 is 0. And 9 minus 1 is 8, right? So it's 8 over 4, which ends up to be a slope of 2. Okay? 8 divided by 4 is 2. So now I can identify if it's partial or direct, and I can tell right away it's going to be partial because when x is 0, y is 1. That's how I know. But we can find out another way, which is by graphing it. Okay? So the first trigger to me is this point here, because if it doesn't have 0, 0, If y isn't 0 when x is 0, then it's got to be partial. But let's see. What we can do again is pick a point and then use our slope. So I'm going to start with this point because I like it. It's a nice easy point, 0 and 1. So when x is 0, y is 1. So I can draw a dot right there. And then my slope is 2, which is the same as 2 over 1. Again, if I'm going quickly, it's okay to pause, okay? So this slope here tells me up 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1. So it's just my step pattern, up 2 over 1, up 2 over 1, up 2 over 1. Do that a few times. Create enough data so you can make a line out of it, which theoretically you only need 2 points, but and keep going in both directions. And there's my graph. And so if I didn't know before that it was partial variation, now you do know because it's not passing through the origin. Kind of the way I drew it, it looks like it is, but it's not, right? So there's all 3 points. Let's do it on Desmos as well. And I'm going to use these same points again, 0, 1, and 4, 9. And I'm going to put them in the Desmos and see if we get the same graph. Okay? So if you can flick with me to Desmos. I'm just going to erase these ones and start over again. So add item, table, 0, 1, 4, 9, and delete these ones. Okay, so add those points. Again, pause if I'm going too fast, but now I'm going to go to expression. This is the tricky one. You go y1, squiggly line, approximately equal, that means 2. Then you have to hit m, x1 plus b. And there's our line, just like we drew it. Okay. And this tells us that m is 2, which is the slope, which is what we calculated. So that verifies our calculation. Shows us again that it does not go through 0, 0, therefore it's correct, and that our graph is correct. Okay? This is getting to be a long video too. But one more question, and that's going to be finding the slope of all these lines. Okay? So I'm going to start down here. Again, pause if you need to catch up, but I'm going to start down here, and here's the first line, and I labeled it A, and we want to find, you'll see right away that I put in some more numbers on this, and I was just following the pattern. See how it goes up 4, 8, right? Sometimes the boxes don't all go up by ones, and that's why I chose this one. Okay? So -4, -8, -12. So I just followed the same pattern down as I had going up. Okay? Which you should do. The scale should be the same. And in this point here, to find slope, you can choose any 2 points. Okay? And I chose on A, I chose these 2. See, I marked them in purple already. And I always draw like a triangle showing the run and the rise. Right? And you might look at that and say, okay, the rise is 1 and the run is 3, but you can't do that. You have to look at the scale on your graph. So the rise in this is 2. And the reason I say that is, see how it's going like -2, -4, -6, -8, -10. It's going up by 2s. Every box is worth 2. So that means that this rise is 2. Okay? But the run, however, the run, if you look, it's going 1, 2, 3, 4, 5, 6. The run is 3. Okay? It's going by the same. And so I like this example because I like you to know that it's nice to be able to count boxes, but you really have to use whatever scales on the grid. Okay? And so that gives us our rise of run, our run of 3. And a fraction is a perfectly good answer. You don't need to put in decimals. In fact, it's better not to. Okay? So jumping up to B, I chose my 2 points here and here. I'm going to make my triangle to enclose those 2 points. So that shows my down. I gotta make my lines a different color. Make it green. Okay, and make another line sideways. Oopsie. And a line here for my run. Make it green so we can see it. Okay, so you enclose you make a triangle out of your line and your 2 points. And here I say my rise. In this case, it's negative, right? Because it's a negative slope, it's going down, and the rise is -8. Okay, the rise is -8, and the run is how much it goes across, and it goes from 0 to 2, so the run is 2. Okay, so -8 over 2, and -8 over 2 equals -4. Now the last two things I'm going to show you are two unique cases: a flat and a vertical. Calculating slope for those. Okay. So for C here, I chose my 2 points, and you think rise and run. Well, the rise is 0. It's not going up at all. Because it's not going up at all, any 0 divided by anything is just 0. So the slope of this line, and that kind of makes sense, right? It's horizontal. There's no slope to that. You know, this obviously has a slope. It has a steepness. This one down here has a steepness. This has no steepness. It's flat. So the slope is 0. So I'm using M for slope and then C. This one is like the opposite of 0. So quickly think in your head, what is the opposite of 0? Shout it out to Mr. Bridge. What is the opposite of 0? And if you said infinity, you're correct. The opposite of 0 is infinity. This slope, a straight slope, is infinity. And the reason is, you've got, say I take these 2 points. Well, I've got a rise of 2. My run is 0. And anything divided by 0 is infinity. And I'm going to prove to you here, because if Google says it's 0, it's got to be correct. I'm going to jump here not to this, I'm going to jump to Google calculator. And I'm going to say, say I divide, what did I say? My rise was 2. So I go 2 divided by 0, infinity. Okay? So if you have a run of 0, like the denominator is 0, then the slope is infinite. And from a visual point of view, if it's straight up and down, the slope is infinite. Okay? So that was a lot of information today, and I know that I'd be surprised if you got finished through this whole note and hopefully played with the Desmos a bit, and that you were very well behaved for Mr. Bridge. And I'll be looking for a good report tomorrow. I don't want anyone to have to spend their last lunch of the March, before March break with me, but you might have to. So, anyways. Yeah, go do some homework questions. And if you don't have time in class right now because we're out, then go home and take them home with you.